All right, folks. Today we are going to be looking at another type of exponential word problems. And that type is going to be your double time, your half-life, and your compounded continuously. All right, so let's think about what an exponential function looks like. An exponential function looks like a times b to the x. You got your starting value times your base raised to the x. Well, compound interest is a form of exponential. Instead of a, we've got our principal, and then our base is the entire thing of 1 plus your rate over the number of times compounded, and our x is the number of times compounded times your time. So it's still an initial amount times your base raised to your exponent. For growth and decay, it's the same thing. You've got your initial amount times your 1, either plus or minus your rate, depending on if it's growing, you use the plus. If it's decaying, you use the minus. And then raised to our time, which is our x. Okay. Well, we have one more type of compounding that we're going to look at, and that is our continuously compounded interest. And it's just exactly what it says. It's continuously compounded. It's not compounded only a certain number of times. It is always being compounded. All right, and this formula is known as the PERT formula. Okay, so your future value here is P times E raised to the RT. Now, we talked about E the other day. E, we know, is just like pi. It represents a specific number. And if you forget, remember you can always go in the Desmos. And you can type in E, and it's going to tell you what that value is. So our value for E, excuse me, is 2.718, etc. Okay. It is an irrational number because it keeps going forever with no repetition, and it doesn't stop. Okay. Now, the P, the R, and the T stand for the same thing. The P is your initial amount. The R is your rate, and T is your time. So let's see how this is going to play out in these problems here. All right, finding the future value. A loan shark lends a gambler $1,000 to cover a debt. He charges 35% annual interest compounded continuously. How much does the gambler owe the loan shark at the end of 1 year? At the end of 2 years? All right, now, I do want you to look right here. It says compounded. With your growth or decay problems, it does not say compounded. It either says increases, decreases, appreciates or depreciates. It gives you some word that either means it's going to grow or it's going to decay. It doesn't say compounded. So if you see the word compounded, you need to know that it's either compound interest or it's continuously compounded. How can you tell the difference between the two? Well, obviously, the key word for knowing that it's continuously is going to say continuously. So we're going to come right here. All right, so the future value. What is our initial amount? It is the 1,000. All right. Our E is going to stay E. It is actually an E. So you're going to type in the E in your calculator. Your rate as a decimal will be 0.35. And our first time that we're asked to find is 1 year. So let's come right here. Let's see, we've got 1,000 times E raised to the 0.35 times 1. Well, 0.35 times 1 we know is 0.35, but I'm just going to go ahead and put it right here. Remember, 0.35 times 1. You got to put it in parentheses. So at the end of 1 year, without making any payments whatsoever, this person would owe the loan shark $1,419.07. All right, how would this change for 2 years? All right, well, the only thing that's going to change is that this 1 right here will change to a 2. So let's see what this person would owe the loan shark at the end of 2 years. All right, so we got 0.35 times 2. So I'm going to come over here and just change this 1 to a 2, and let's see what we get. Okay. All right, so at the end of 2 years, if he's not made any payments, he's going to owe that loan shark $2,013.75. All right, so again, you look to see if it says compounded. That lets you know it's not a growth or decay problem. And then you look to see if it's just regular compounded. It will say, compounded quarterly or compounded monthly or something like that. That's just the regular compounding. But if it says continuously, you got to use the PERT formula. So right here, here's our key words. Compounded continuously. All right, Cindy invests the money at 2%. So that's our rate. 0.02, compounded continuously. That lets us know it's the PERT formula. After 6 years, there's our time, she has $1,691. So that's what she's ended up with. What was the initial investment? So we're trying to find the principal. We're trying to find what we started with. All right, so let's set it up. The future value is equal to P times E raised to the RT. Our future value, or final value is what some people call it, was $1,691.25. We don't know the P, so that's going to be our unknown. So I'm just going to leave that as P. We got E raised to our rate, which is 0.02. And then our time is 6. All right, now ask yourself, what is the only unknown that we have here? And a lot of students will say, we've got 2 variables. Remember, though, the E actually has a value. So our only unknown is the P. So we could actually evaluate this right here. Now, could you do left side, right side? Of course you can. Okay. All right, so I'm going to come right here. I'm going to say E raised to the parentheses, it might be helpful, y'all can see, 0.02 times 6 inside the parentheses, and this is what I get right here. So what I actually have is the 1691.25 is equal to 1.127, I'm round it to 3 decimals, times P. Well, the opposite of multiplying by 1.127 is dividing, because we're trying to get that P by itself. All right, so let's do this. We've got 1691.25 divided by 1.127. All right, so here we would need to, Cindy would need to invest approximately $1,567. And let's see how close we were. All right, I'm going to do left side, right side. So y equals, remember this doesn't have a variable on the left side, so that's why we're doing y equals 1691.25. And then right here I've got x, because we can't use a p, so we're going to use x, times e raised to the 0.02 times 6. And then let's see what they intersect. All right. It's coming right here. I see they intersect at about $1,500. So the unrounded version just says basically $1,500. So the rounded version is $1,567. But that's still close enough that it would allow us to choose the correct answer if this was a multiple choice problem. Now I know what you're saying. I'm just going to do the left side, right side, and that's perfectly fine because that would still give you enough information to choose the correct answer. All right, example 3, notice here it says finding time. Chelsea put $7,500 into an account paying 5% compounded continuously. That's that word continuously and compounded, so that lets us know it's the PERT formula. She now has $10,643.01 in the account. So she started with $7,500 and this is what she's ended up with. How long was the money in the account? So let's set this up. As I always say, write your formula down. That will help you in setting up the problem. All right, what was the final value? Final value was the $10,643 and some change. So 10,643.01. The initial amount was $7,500. Okay. All right. Then here, we're going to come right here and we're going to do E. Our rate is 5%, so 0.05. And time is what we don't know, so we're going to leave that as a T. All right, so we've got two ways of solving this. We could do natural log, or I would just go ahead and say, I would strongly suggest just doing left side, right side on this one. All right, so I'm going to come right here and put my left side in. So we've got y equals 10,643. Oops. 10,643.01. And then right here on the right side, put it in line 2, 7,500 E raised to the 0.05 X. All right, and let's see where they intersect. All right, so my Y is 10,643, so that means it's almost 11,000. So notice right now my Y is not going up to 11,000, so I'm going to come out here and go to about 11,000. And there is where I can see they intersect. So let me focus on this right here, find their intersection. All right, I can see they intersect right there. All right, so approximately how many years has it been? Well, here, T is approximately 7 years. All right, finding the rate. Give you just a few more seconds to finish copying that down just in case, or practicing with Desmos. Actually, this would be a great time to pause the video just to make sure that you know how to do it. So pause it for about a minute or two to see if you know how to put this in Desmos correctly. All right, hopefully you did do a little practicing with Desmos. Let's go ahead and look at example 4. In example 4, they're asking us to find the rate. Okay, so Dash puts $4,125 into an account, paying continuously. All right, so that's the key word again, continuously. That lets us know it's going to be a continuously compounded problem, the PERT formula. If he keeps the money in the account for 5 years, he will have $4,913.89. What is the interest rate? All right. So let's write down our formula. FV equals the PERT. What is the final amount? The $4,913.89. what was his initial amount? The $4,125. Then we've got our E. We don't know the rate, but we do know the time. Okay, so the time is 5 years. So I'm going to put the 5 first and then put T for time. All right, so once again, since we've got an E, a base of E, we would have to use the natural log. Now, it's easy to do natural log, but depending on what class you're in, you may have covered natural log by now or you may not have. So again, I would just suggest doing left side, right side for this one. All right, so coming right here. The left side does not have a variable, so I'm going to do the y equals. So we got y equals 4913.89. All right, the right side is 4125e raised to the 5x. So remember, we can't use anything but x. All right, so pause for about a minute and let everybody type this in. You could do a split screen. Actually, you don't need to do a split screen because this is being projected on the board. It's not a Friday. All right, so I need to go up to my y-axis to about 5,000. So I'm going to shrink this right here. So I hit about 5,000. And I can see my two lines intersect right here. So I'm going to kind of magnify that, focus on that point of intersection. And the reason why is because I want to be able to see their intersecting points. Let me make these a little thicker so you can see. All right, because I want to see when my colored lines intersect, because when it's really small, like it originally was, when you tap on it, you might accidentally tap on the y-intercept and get the wrong answer. So I want to make sure I get the right answer. So here we get T, which that should be R, not T. See, if I was in actual class, somebody could correct me. So we're looking for R. So our rate here is 0.035. So as a percent, moving that decimal 2 places, it would be approximately 3.5%. Now, how could you check? We could actually come in here and substitute in. We got 4125 E raised to the 5 times point. Ooh. Try that again. Why is my parentheses not working? All right. All right, e to the 5 times point. Y'all see that my parentheses is not working. I don't know why. 5 times 0.035. There we go. All right. And we get what the output should be. So that lets us know the answer is correct. All right, now for our last two examples, double time and half-life. Okay, double time. Double time is just like it sounds. If you're doubling something, what are you doing? Right, you're multiplying by 2. You're doubling it. Okay, well, since it's always going to be doubled, your base is always going to be a 2. So you're going to have a times 2 raised to the n over t. Maybe I should change that n. Let me change that n to a different variable so it won't be as confusing because it's not the number of times compounded. And call that total time over ST, special time. All right, so let's talk about this right here. A is your initial amount, just as it always been, whether they call it an A, a P, a X, a V, whatever. Whatever is in front of the base is always your initial amount. It's the starting value. Okay. Here we have a base of 2. That base is always going to be 2 because you're doubling it. All right. But with double time and half-life, you have 2 times that you're dealing with. You have your total time, which is the actual, what it says, total time, and then you have the special time. That is the time it takes to double, or in half-life it would be the time it takes for half of it to disappear. And this is pretty easy because the base is always going to be 2. All right, suppose a water tank is infested with 100,000 E. coli bacteria. The colony doubles every 4 days. Determine how many bacteria are left after 38 days. Okay, so let's look and see what we got here. 100,000, that's our initial amount. That is our A value. The colony doubles. So how do I know it's double time? Because it literally says that it's doubling every 4 days. Now 4 days, is that the total time or is that the time it takes to double? Right, that is the time it takes to double. So this is your special time. Determine how many bacteria there are after 38 days. Okay, so they want to know after 38 days how many are left. So this is our total time. All right, so we're going to come right here. We're going to say the final value, or y equals, either way you want to say it. Our initial amount is 100,000. Base of 2, since it's doubling. All right, the total time is 38. That goes in the numerator. And the special time is 4. Now, this is 38 days over 4 days. You always want to make sure the units for the time are the same. If they're not the same, you need to convert them to the same units. All right, so let's see how many bacteria. All right, so we got 100,000 times 2 raised to the parentheses 38 divided by 4. All right, now bacteria are what we call discrete units. You can't have a part of a bacteria. So since they are discrete units, you have to round to the nearest whole bacteria. Okay, so we got 724077734. That 3 right there is going to keep that 4 as a 4. So we're going to round to the nearest whole unit. So we would end up with 72,407,734 bacteria in only 38 days. Now, can you imagine what the door handles and buttons and all that kind of stuff that you touch every day are like? If it doesn't get clean with some kind of antibacterial or cleanser, think about how many bacteria or viruses might be growing on that, and you don't go washing your hands or using hand sanitizer. That's the reason we get so sick. All right, half-life. All right, so if it's half-life, you're taking how much? Yes, you're taking half. So if you're taking half, guess what the base is going to be? You got it, a half. So it's just like double time with the exception of y equals or final value of future value equals your initial amount, but instead of a 2 here for doubling, we're going to use 1/2 as your base always. And a lot of you may have already done this since you probably went through science already. And you talked about half-life there. Okay, so let's read this. Lead-209 decays to a non-radioactive lead over time. The half-life of lead 209 is 3.3 hours. Suppose that 20 milligrams of lead 209 are created by a particle physics experiment. Determine how much is left after 2 days. All right, now you're going to find a lot of times with half-life, we're going to deal with substances that have a number in their name. Okay, that 209 is not part of the problem. It is simply a name. That's it. So you'll never put that 209 in your problem. So make sure you don't put the number that's in the name of the particle or the substance in the problem. All right, so our future value, or final value, however you want to call it, is equal to our initial amount. All right, so we started with 20 milligrams. Okay, so that's our A value. All right, how do I know it's half-life? Because it literally says the half-life. So I know the base is going to be 1/2. All right, the 3.3, the half-life of lead 209 is 3.3 hours. That is the special time. That is the time it takes for half of it to disappear. So 3.3 hours. That special time goes on the denominator, so we got 3.3 hours. How much is left after 2 days? That's the total amount of time, so we got 2 days. Now look at that carefully and see if there's something I need to fix. Yes, this is days and this is hours, so I need to convert either hours to days or days to hours. Okay. All right, I'm going to convert days to hours. So we got 20 times 1/2. How many hours are in a day? 24. So 24 times 2 gives us 48. So we got 48 hours over 3.3 hours. Now that all of our units are the same, we could actually come in here and solve this. So we got 20 times 1/2 raised to the 48 divided by 3.3. And we can see that hardly anything is left of this material. All right, so let's see. That's going to be 0.0008. And let's see, milligrams. And that, ladies and gentlemen, is it. Make sure you put your name and date on the notes and submit your notes.